Aloha, welcome to our video review for 1.3a Scientific Skills. The goals for the video today will be to list the skills that scientists use, to describe the measurement systems most scientists use, to explain how scientists communicate results, and then finally to compare light microscopes and electron microscopes. So what are scientific skills? These are the skills that scientists use in order to do science according to the scientific method. First and foremost is observing. Remember, science is based on data, and data is basically our observations. So we have to be able to observe, and that's with all five senses. Scientists will compare and contrast their observations. They'll classify this, and we'll talk about that a little bit more. They use models and simulations. Models generally are representations of things that are really big or really small, and a simulation is more of a model that shows a process. Scientists also measure, they analyze data, and ultimately they have to communicate their results so the world would know what they're studying. And finally, through science, they're able to make predictions. The lessons will go through these in a little more detail, but I wanted to go over them with you real quickly. So we talked about measuring a little bit as being a scientific skill, and that leaves us with which measurement system do we use? We have three choices here in America. We can use the English system, we can use the metric system, or we can use the SI or System International system. Now, the simplicity of the metric system is down here, and this is what I wanted to show you. SI is what scientists use. It's basically a simplified form of the metric system, but it's set for scientific use. For example, we have length, there's 1 unit. For mass, there's 1 unit, and for volume, there is 1 unit. So we have the meter, the gram, and the liter, and that's what we use for each one. Under the imperial or the English system, that's where we start to see a lot of conflict. With length, we can measure in miles, in yards, in feet, and in inches. So a whole bunch of different ways to measure those things. With mass, we have a grain, we have a drachm, and we have a pound. So again, a whole bunch of different units it can use. And then for volume, we can use it in ounces and gills and gallons. So a lot more confusion there. The SI system, and the reason it's used for science is because quite simply we have one base unit of measure. Now, we get around with these needs of bigger things and smaller things by using prefixes, and we can see those here. You've heard these before. Kilo is 1,000, deca is 10, deci is a tenth, centi is a hundredth, and milli is 1,000th. So by using the prefix, we're able to modify this single unit here and make it work over a vast scale of sizes. Now, sticking with the metric system or the SI system, we have our base units of measurement. In science, these are the reasons we use them. Is it's simple, like we mentioned, there's only one of them there. So for length, we have the meter, okay? For area, we have the metered squared or the centimeter squared, depending upon the size of the object that we're measuring the area for. For mass, we use grams. For the weight, remember, weight is a force of gravity. So for that one, it's going to vary a little bit. We generally like to use newtons in science, but it's not a normal measurement. It's actually a calculation based on the mass and the force of gravity. For the volume, we use the liter or a cubic centimeter. Okay, and then finally in temperature, most time in science labs we'll use degrees Celsius, but when we start getting really super cold, then we'll switch over to the Kelvin scale. The key to science is communication, and part of that communication is making that data useful or so it's visible so people can see what's going on, and we call that analyzing our data. So quite simply, the first step is to put it into order, and then we can start to manipulate that data. When we put it into order, we have two primary ways. We can use a table or we can use a graph, and you can see an example of each. Down here, we have our data table, and that just kind of plugs the data out, helps us to organize it, makes it so it's there and easy to find per se. Then what we'd like to do is we'll take it and we can change that data into a graph, and by doing so that makes it visual, and that makes it a little bit easier to see and spot trends or patterns and things like that. Okay, the last thing I wanted to show you a little bit about is to talk about microscopes. Microscopes work by using lenses. Now, with a lens, what it gives us the ability to do is we refract or we bend the light. So here is our lens. We can see one over here, and if we take our object, you can see how a light wave is going to come through here, and through the medium of the lens, it's going to bend a little bit. And as such, what it does is we're able to take this image here of this little bug, and by bending that light, it creates a larger virtual image that we can take a peek at. Okay, the microscope started off with a single slide down here, just a magnifying glass per se, and then they started to put two of them together to get a compound microscope, and now we have ones that have multiple objective lenses, and these are kind of like the ones that you'll find in a classroom or the one we see right here in our picture. Okay, a couple pieces and parts of the microscope that I want you to be familiar with. The eyepiece, obviously where you look at. We have the stage down here, which is what holds the slide and what we're looking at. We'll have some kind of a light source, be it a light bulb or a mirror here, that'll shine light upwards, and sometimes they'll shine downwards, and that'll give us where we have our specimen here on the slide to look at. Okay, the lessons, we'll go over these a little bit more in detail and talk about the difference in electron microscopes as well. But that's about it for this one. I hope that it helps out a little bit, and we'll see you for the next video.